All right, when we talk about z-scores, the z-scores are used when you can't see one of the numbers on your standard deviation curve. Okay, so yesterday we talked about making the curve. Friday we talked about making the curve. We're still making the curve. Okay, but all the questions that were asked before were numbers that were actually on the curve. Like, you know, we have one, everything, what percentage is below 73? And you found 73, added up all the percentages below. Okay, z-scores will tell you, listen up now, will tell you how many standard deviations above or below the mean your given score is. So when you find the mean and then the standard deviation, you got a bunch of scores. Like, you know, I gave you the example the other day of the test, right? My mean was 66 and my standard deviation was 18. So between 66 and the first standard deviation to the right, I went from 66 to 84. Well, there were obviously scores like 75. That's in between 66 and 84, right? But you didn't see that number at the bottom of the chart. So if I want to know what percentage of the students made 75 or higher, I would use the z-score part to figure out that percentage. And that chart that you picked up helps you figure it out. Okay? The formula is very simple. The formula is very simple. X1. Now listen. X1 right here, this is whatever the score is that you're given. That's whatever score that you're given. The mean will be given, the standard deviation will be given. Down there in example 1, it says you take the SAT and score 1100. So X1 is 1100. All right? If you look at example 3, it says you run a race or the average runner has a mean time of 58, but you ran it in 52 minutes. Guess what? 52 minutes is your X1. Okay? So it's that, the X1 is the time that's in between the lines on your standard deviation bell curve. Now, when you use this formula, if you get a positive z-score, the data is above the mean or to the right. That's pretty self-explanatory, right? When we make the chart, the normal distribution curve, we put +1, +2, +3 on the right, correct? So if it's positive, it's to the right. And so likewise, a negative z-score means the data is below the mean. Okay, so it's less than the average. I'll extend that so you guys can see it. Okay, so if the z-score is negative, it's below the average. Now, think about this. Your number that you're putting in is going here, and you're subtracting the mean, correct? So if my mean was 2, if my mean was the number 2, but I put a 4 in X1, what's 4 minus 2? 2 is a positive number, right? Okay. So if I'm above the mean, I'm going to get a positive number. Think about this, though. If my mean, what did I say the mean was? 2? My mean was 2, and I put in a 1 there for X1. What's 1 minus 2? 1 minus 2. -1, right? So I get a negative number. If I'm below the mean, I get a negative number. If I'm above the mean, I get a positive. That makes sense, does it? Okay. That mean on our continuum, when we draw the bell curve, remember, we put the mean at what number? What do we put right here? 0, right? 0. That's where the mean goes. Okay. You don't have to. No, that's just giving you a visual right there. All right. Now, one thing to keep in mind, the chart that you got, the front and back chart, on one side you have negative z-scores. You guys see that? One side's negative, the other side's positive. Don't lose this chart. You're going to need it. Okay? The chart, this is key. You want to write this down. The chart only shows less than. Okay, this will make more sense in a second. In some of your problems, it's going to ask how many scores were less than, blah, 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 or what percentage of scores were less than. That's what you see on the chart. Those are the items that are less than, or everything up to a certain point. If you want to know how many are above, if it asks how many are greater than, what percentage are greater than a certain score, so if it says above or greater than, you need to take 100 minus your percentage. Whatever percentage you get from the chart, you subtract from 100 if you want to find out above. If it says less than, don't subtract. If it says above, subtract from 100. Here's why. You might get something, let's say your average test score was an 85, right? And your standard deviation was 5, so your first standard deviation would be 90, right? You might want to know what percentage of students made an 87 or less, okay? So 87 would be in between those two numbers, correct? So 87 or less would be all of these percentages, right? The z-score percentage is going to give you all of these percentages. But what if you wanted to know 87 or above? You would take these percentages and subtract from 100, because all the percentages add up to make what? What do they make? 100. So if the z-score gives you everything less, all right, and you want to know what's above, take 100 and subtract what's less, and you'll have the remaining percentages. Okay? We'll talk about that a little more as we go on. All right? But if it says less than, you keep the percentage you find on the chart. If it says above, take that percentage from the chart, subtract it from 100. Okay? Above, subtract, less than, keep. So let's look at an example. All right? Example 1 says you take the SAT and score an 1100. So that is your X1, because that's what you scored. Okay? And I'm telling you that, I kind of did that prematurely. I should have waited just a second. But because the next sentence says the mean score for the SAT is 1026. So that's your mean. The standard deviation is 209. So let's take that information and let's make a little bell curve real quick. Guys, we ought to be getting really quick at these. Okay, you got some room there, make a little small one. Okay, and when you make them, start with 0. Okay, there's 0. You got 1 left, 1 right, 2 right, 2 left, 3 left, 3 right. And again, it's not perfect, okay? But put your percentages in. All right. So there's my percentages. What's the average? What's the average or the mean? 1026 goes in the middle. And what's the standard deviation? 209. So this is why you really need a calculator for the first part today, okay? Because having to add 209 every time, that's a little more difficult than what we've seen. All right, I'm going to help you out with it, okay, for time's sake, because you know how to do the charts. We did them yesterday. To the right, when you add 209, you should get 1235, 1444, and what's that say? Can you read that? 1653. Okay. To the left, when you subtract, you get 817, 608. All right. All right. 817 to 608. And then what, 399? Okay. So, that's what your table looks like. What was your score? 1100. Do you see in these numbers in red the number 1100? No. Okay, so let's put it on there. Okay, the number 1100 is going to be in between these two, correct? So it's somewhere in there. That's 1100. Now we can't see the exact percentage, can we? That's why we use the z-score. So A right here tells us to find the z-score. Well, the formula is x1 minus the mean over the standard deviation. So what did I tell you to put in place of x1? The score given, which is 1100, minus what's the mean? 1026 over the standard deviation, which is 09. Now we're going to round this to 2 decimal places. Okay, so type it in, type that in. Okay, use your fraction button. If you don't remember on those calculators, it's the one with the n over d. Second column, third button down. Okay, n over d, 1100 minus 1026 over 209. Shouldn't be a negative. All right, you got 1100 minus 1026 over 209. Convert it to a decimal. It's what? 0.35. Yes, 0.35. All right, 0.35. Now, here's how you use math left-hander. Oh, how do you go fraction to decimal? Hit math, down. No, maybe you just go down one. Right there, decimal. Okay. There. All right, so here's how you read the chart. Now listen, this is a key. 0.35 is your z-score. So when you read this chart, go to the, is it positive or negative? Positive. So go to the positive chart, which is the one with all the positive numbers. You see it? All right. On the left-hand side, you want to go down to where it says 0.3, and then you go over to where it says 0.05, because your z-score, guys, is 0.35. Down to 0.3, over to 0.05. We're on the positive side. Guys, listen. It doesn't say 0.35. You need to go on the left-hand side, go down to where it says 0.3. Okay? And then you're going to go over to the one that's underneath 0.05. 0.35. 0.3, 0.05. Okay? 0.3 plus 0.05 is 0.35. Got it? Go to the positive side. So, your z-score here, your z-score, does everybody see the z-score? 0.6368. Do you see that? Okay. Now, that z-score is a percentage. How can we make that decimal into a percentage? Times it by 100, or 2 places to the right. If you multiply it by 100, or you move the decimal 2 places to the right, your percentage is 63.68%. What that tells me is the person who made the 1100 scored as well or better than 63% of the people who took the test. What percentage would be right down the middle? Right down the middle. 50%, right? This one's just to the right of 50, correct? So, about 63%. That seems right, doesn't it? Okay? So that person scored 63 as well or better than 63% of the folks. Now, B, what percent of the test takers made below 1,000? So, what are we going to put for X1 on this one? 1,000, right? Okay. So if we want to find this z-score, we go 1,000, because that's our new score that they've given us, minus the average. What's the average? 1,026 over the standard deviation, which is 209. Now, listen, is 1,000 above or below the average? Below. So what kind of z-score are we going to have? We know it's got to be negative. So type it in. 1,000 minus 1,026 on the top over 209. Round to 2 decimal places. Anybody in here get negative 0.12? Yeah. Okay. So your z-score is negative 0.12. So which side are we on our z-score page? Negative side. So we want to go down to negative 0.1. Negative 0.1. Go down to there. And then go over 0.02. You see that? Okay. So we go down, and look, negative 0.1 is the next to last one from the bottom. You see it? And then we go over to 0.02, which is third from the last, because my z-score is negative 0.12, right? So go down to 0.1, because that's the first part, down to negative 0.1. The back end is a 2, correct? So 0.02 in the back end. And the decimal you guys see 0.4522? Is that the decimal you saw? Where are you at? You went to negative 1. We need to go to negative 0.1.
Oh, okay.
And then over to 0.02. That's right there. So, what's the percentage? All right, 45.22%. Now, look at the question again. Does it say below or above? It says below, right? So this is right. What if it had said above? Subtract it from what? 100, that's right. But it says below, so we can keep it. If it says below, keep the percentage. That one just wanted to know how we did. We did better than 63%. All right, the second one wants to know below 1,000. Okay, so 43% of the people taking this test made below 1,000. All right. All right, go to the next one. We'll start it. Let's see. I got to change something on this one. I tell you what, let's do this because I got a bunch of, listen, I had a bunch of things that I changed on this one. We're not going to worry about, what you made. Okay? We just want that this math test had a mean of 80 and a standard deviation of 5. Let's make that bell curve real quick. Look, I'm not even, hey, I ain't even, no, I'm not going to make it great right here. 0, 1, negative 1, 2, negative 2, negative 3. 3. All right. Biggest thing I'm worried about right here, I'm not even worried about getting my percentages on because we're going to get the percentages off the z-score. All right. So let's get our numbers on it. What's the average for the mean? 80. Standard deviation? 5. That should be pretty simple, right? Add 5 to the right, subtract 5 to the left. So 85, 90, 95, 75, 70, 65. Any questions about that part? We're not going to do the end either, the comparison, so don't worry about that. All right, part A. What percent of the students scored, what's the next word? Above 82. So what do we know we have to do here? Whatever percentage we get, we have to subtract. We'll do that at the very end because we want to know what percent made above 82. So the first thing is to check, is 82 one of these numbers we wrote down? No, it's somewhere in here though, right? 82 somewhere in there. All right, so let's figure it out. What's our x1 going to be? 82. Remember I said x1 is the score given, correct? We are given 82. What's the mean? 80. What's the standard deviation? Should be 5. All right, so plug that in real quick. Punch that in. Punch that in. See what decimal you come up with for your z-score. You ought to be able to do it real quick without having to punch the whole thing in because 82 minus 80 is 2, right? 2 over 5 is what? All right, so now listen, 0.4. What number can we put behind this 4 right here and be okay with? A 0. Okay, go ahead and put that in, okay, because it is 0.40. You don't have to write it, right? But when we go to look at the chart, it's going to make it a whole lot easier because we're going to go on the positive one, we're going to go down to 0.4, and we're going to go right to 0.00. Yes. So if you go down on the left-hand side to 0.4 and you go right to 0.00, the percentage or the decimal is 0.6554, right? Y'all see that? Yes. You need a what? Okay, well, grab that pass off the floor and go. All right, so what percentage is that, guys? Yeah, 65.54%. Now, listen to me. That's the students. 65% of the students made up to that 82. But it wants to know above. So what do you do with this percentage? Subtract from 100. Okay? So to figure out, come on. So you take that percentage and you subtract it from 100. 100 minus 65.54 is, it ought not be negative. You got to subtract it from 100, not subtract 100 from it. Right? So think about this for a second, okay? Because this is a test. I'm taking it off. The average of the test was 80, right? So 82, that's above average on this test, right? So it's probably fewer students than the majority that made above average test scores, yes? All right, so 34% makes sense. 65% does not make sense because the average was 80 and 82 is above the average. The average is right in the middle. So if we go above the average, it's got to be less than 50. All right, because the 50% cutoff is right here in the middle. You understand that? Okay. So since we're above the middle, we've got to have less than 50% of the people in this group. All right. Now, next question. If there were 25 students, how many scored below 71? So we got to find the percentage below 71 and then multiply that percentage by 25 because they gave us that. Now, does anybody see 71 in the blue numbers? No, but it's about right here, correct? So, if we're going to figure that out, we're going to take 71, which is what we're given, correct? Subtract what? 80, because that's the mean, over the standard deviation, which is 5. What kind of z-score are we going to have here? Negative. Okay, good. Negative 1.8. That's our z-score, right? Now listen, that means we're going to go down to -1 and right to 0.8. Is it -1.8 or -1.08? Yeah. Okay. Excuse me. That means we're going to do this. Okay. We're going to go down to -1.8 and we're going to go right to 0.00. I'm sorry. Because -1.8 is on the left-hand side, isn't it? Okay. Yeah. All right. So when we go down to -1.8, and we go all the way to the right to, yes, to 0.000, we get 0.0359. Is that what you said? All right. So, what percentage is this? 3.59%, correct? But do they want the percentage on this one? No, they want the number of people, correct? Well, no, 3% of how many people? 25. They said if 25 students took the test. So, look, no, wait a minute. We want the percentage. We want to find the percentage of the 25. So here's the decimal for the percentage, right? Multiply the decimal times 25. 25 times 0.0359. Now remember, this got to be, we got to round to a whole number because we're talking people, okay? What'd you get? 0.89, so it's about how many people? No. One person. 0.89, right? Which is about one person. Think about it. 3% of 25. That's a small percentage, correct? So one person would make sense. 90 wouldn't make sense because there's not even 90 people, right? Okay, I know where you're thinking. Okay, but think about what makes sense. 3%, small percent of 25. One person, that's a small amount. All right. Do number 3 real quick. Yeah. Yes. Well, not a milestone. It'll be on your benchmark. You'll have the Z-score sheet. Keep up with it. I don't want to print anymore, to be honest with you. All right. Do the third one, guys, on your own. Draw. Listen. Draw the curve, because A, you can just use the curve. It's real easy to do A. B, you'll have to find a Z-score. A, you don't have to, because that number is going to be on the curve. right, so if you haven't finished A yet, look at it with me, okay? It says what percent of the runners ran it in 54 minutes or less? When you draw your curve, hitting 54 on the curve, it's from the lines, isn't it? So look what I did. 54 minutes or less. I wrote in all the percentages that we learned the other day from 54 minutes or less. 0.2, 2.2, 13.6. If you add all those up, what do you get? You get 16, right? Adding those percentages, 0.2 plus 2.2 plus 13.6 is 16%. You did it the long way, did you still get 16%? Okay, so about 16. Remember, standard deviation curve is close. All right. So we said 54 is on the curve, so we don't have to find the z-score with this one. You can. It's like, what did you say it was? 15. No. Hey, what did you say you got when you found the z-score? 15 point what? 15.87. Okay. Which is almost 16. Now, when you do the second part, 60 minutes is not, listen up, 60 minutes is not on the curve. But at 60 minutes or more, so you got to, whatever percentage you get, you got to subtract from 100, okay? So I know some of you still working on 60. I'll give you a couple minutes, then I'll put it up there. Should have a positive z-score on this one. Remember, when you find your z-score, you do what the value you're given, which is 60, minus the mean over the standard deviation. Uh-oh, it's the wrong standard deviation. The value you're given is 60. The mean is 58. Standard deviation on this one is 2. Gives you a z-score of 0.5. Should be looking at the positive page. Go down to 0.5. Right to 0.00. Your z-score, or your z-score decimal, is 0.6915. So this person, look, that 60 is above average, so it's about 70%, but we got to subtract that percentage from what? 100, because we want to know the or more part. So we'll take 100 and subtract 69.15%. And the way I got that was moving that decimal. All right, and the solution is 30.85%. So 30%, listen up, roughly 30% of the runners, took 60 minutes or more. All right, flip over to example 5. We'll skip 4. All right, real quick, make our curve. That's terrible. All right, close enough though. The mean score is 830. Standard deviation is 39. So let's see, I got 869. My first one, 908 on my second one. On my third one, I got 941. Believe that. Oh, wait a minute, that ain't right. No, 947, I'm sorry. That's a 7. Back this way, I got 791. 752. And 713. Now, the question's right here. All right, if there were 500 students taking the test, how many would make an 880 or higher? So we want to know the percentage that make 880 or higher, and then we want to multiply that percentage by 500. 880 is somewhere in this range. So we're talking about a small group of kids, right? Making 880 or higher. It's way far over there on our curve. So let's do our z-score. So we want to know 880 minus, what's the average? 8 what? 830. What's the standard deviation? 39. So we put that in, and we'll get a decimal to, as best we can, to 2 spots. What y'all got? 1 point what? Did anybody else get 1.28? All right, so 1.28 is your z-score. Here's what that means. Go down to 1.2, go right to 0.08, and look at the decimal that you have there and write it down. Down to 1.2, trace it over to 0.08, and your decimal should be 0.8997, is that right? So what percentage is that? All right. Now, we want to know how many made that or higher. That percentage represents everybody below that, correct? Subtract that from 100. So we go 100 minus 89.97. And this is going to give us a percentage. It's almost what percent? It's about 10%, right? It's 10.03. So 10.03% of the students made 880 or higher. How many students are in this scenario? 500. So if we want to find 10.03% of 500, we need to take 500 and multiply it by what? Move the decimal 2 spots left. So multiply it by 0.1003. $50.15, but we wouldn't write a decimal for students, would we? So about 50 students made above 880. Okay? Tomorrow we'll do some practice with that. Again, it's going to be on D2L, so go home tonight, check it, look through it. That's it for today.